Welcome back my YouTube channel. Today we are going deep into the world of one of the most impressive container ships ever built, the OOCL Hong Kong. This enormous vessel is a true giant of the ocean, created to carry massive amounts of cargo across international trade routes. When the OOCL Hong Kong entered service in 2017, it made maritime history with a capacity of 21,413 TEU, meaning it could carry more than 21,000 standard 20-foot containers. At the time, it became the largest container ship in the world by carrying capacity and was the first container vessel to cross the 21,000 TEU mark. The ship was built by Samsung Heavy Industries in Gyeogyang, South Korea, and was part of OOCL's G-class of ultra-large container ships. The first thing that makes the OOCL Hong Kong so impressive is its enormous exterior design. The ship measures approximately 399.87 meters in length and 58.80 meters in beam. To understand that scale, imagine a vessel stretching almost 400 meters from bow to stern. Its enormous hull gives it the appearance of a floating skyscraper lying horizontally across the ocean. The ship rises high above the water, with its container stacks creating multiple levels of cargo that can be seen from a considerable distance. Its registered specifications list a depth of 32.50 meters and a highest point of approximately 73.5 meters above the baseline. The overall design is not simply about making the ship bigger. Every part of the hull and deck arrangement has been developed around the efficient movement of enormous quantities of cargo. At the front, the bow has a strong, streamlined shape designed to push through the water efficiently. A ship of this size has to deal with enormous resistance from the ocean, so the shape of the hull is extremely important. Instead of looking like a traditional passenger ship, the OOCL Hong Kong has the unmistakable appearance of a purpose-built cargo machine. The bow extends forward like a massive steel wall, while the long hull provides the space required for thousands of containers. Behind the bow, the open cargo deck stretches toward the stern, with container stacks arranged in carefully calculated positions. The container arrangement is one of the most spectacular parts of the ship. Thousands of steel containers can be stacked across the deck, creating rows and columns that look almost like a giant industrial city. Containers are secured using specialized locking systems so they can remain in position during long ocean voyages. They may contain electronics, clothing, machinery, food products, furniture, industrial components, and countless other goods. Every container represents cargo moving between different parts of the world, and the OOCL Hong Kong was designed to move enormous quantities of that cargo efficiently. The ship's dimensions also give an idea of its enormous weight. OOCL lists the vessel's deadweight at more than 197,000 metric tons and its summer displacement at approximately 259,277 metric tons. Its gross tonnage is listed at 212,035. These numbers show just how much steel, machinery, fuel, equipment, and cargo are involved when operating a vessel of this scale. But the real headline figure is the cargo capacity. The OOCL Hong Kong is rated at 21,413 TEU. TEU stands for 20-foot equivalent unit, a standard measurement used throughout the container shipping industry. A 20-foot container represents 1 TEU, while a 40-foot container represents 2 TEU. This means the ship's capacity represents an extraordinary amount of containerized cargo. OOCL officially announced the vessel is the first container ship to cross the 21,000 TEU threshold, making its arrival a major milestone in the development of ultra-large container ships. Moving such a huge ship requires an enormous propulsion system. Deep inside the vessel is a giant marine diesel engine designed to generate the power necessary to move the massive hull across the ocean. The engine is connected to the propulsion system and ultimately drives the ship's propeller. A commonly reported specification for the OOCL Hong Kong's G-class design is an MAN B&W11 G95 MEC engine producing roughly 75,570 kilowatts of maximum power, equivalent to more than 100,000 horsepower. The enormous engine operates at relatively low rotational speed compared with automobile engines, but it produces tremendous torque for turning the giant propeller. The engine room itself is a world of industrial machinery. It contains not only the main propulsion engine but also generators, pumps, compressors, cooling systems, fuel systems, electrical equipment, monitoring systems, and many other machines required to keep the vessel operating continuously. Engineers work around the clock to monitor temperatures, pressures, lubrication, fuel consumption, vibration, and other critical parameters. On a ship that can spend weeks at sea, reliability is extremely important. A small problem with an ordinary vehicle can be inconvenient, but a serious mechanical problem on an ultra-large container ship far from land can become a major operational challenge. Fuel efficiency is also extremely important for a vessel of this size. The ship travels enormous distances, and even small improvements in efficiency can make a significant difference over thousands of nautical miles. Modern large container ships are designed to move huge quantities of cargo while using fuel as efficiently as possible for their size. The long hull, propulsion arrangement, engine technology, voyage planning, and operational procedures all contribute to controlling fuel consumption. When it comes to the actual experience of operating the OOCL Hong Kong, it is completely different from driving a car or even operating a smaller vessel. There is no quick acceleration and there are no sudden turns. A ship measuring nearly 400 meters long has tremendous momentum. Every maneuver has to be planned carefully, often well in advance. When the vessel approaches a port, navigation officers work with tugboats, pilots, terminal personnel, and port authorities to guide the giant ship safely toward its berth. At sea, the experience is dominated by stability and controlled movement. The OOCL Hong Kong is built to travel across major ocean routes, where it can encounter calm water, strong winds, large waves, and changing weather conditions. Its enormous size gives it significant stability, although no ship is completely unaffected by rough seas. The bridge crew constantly monitors the vessel's position, speed, surrounding traffic, weather information, navigation data, and route conditions. The bridge is essentially the command center of this floating giant. From this elevated location, navigation officers control and monitor the ship's progress. Modern navigation equipment provides detailed information about the vessel's position and surrounding environment. Radar, electronic navigation systems, communication equipment, GPS-based positioning, engine monitoring, and other technologies work together to help the crew make safe decisions. The bridge team must remain alert even when the vessel is sailing automatically along a planned route because ocean traffic and weather conditions can change. Although the OOCL Hong Kong is primarily a cargo vessel, the ship also has accommodation areas designed for the crew who operate and maintain it. Life on board a giant container ship is very different from staying in a luxury hotel or traveling on a cruise ship. The accommodation is designed around practicality, safety, and comfort. During long voyages, crew members need sleeping cabins, dining facilities, recreation areas, sanitary facilities, offices, and other spaces necessary for daily life at sea. The interior accommodation areas are separated from the enormous cargo deck and machinery spaces. Cabins provide crew members with private or shared living areas where they can rest after working their shifts. Air conditioning is particularly important because the vessel can travel through different climates, from cooler northern waters to hot tropical regions. The crew also needs comfortable dining and recreational spaces because they may spend weeks away from their families while the ship travels between continents. The dining area is an important part of life on board. Crew members require regular meals throughout their voyages, and food must be stored and prepared safely for extended periods. There are also spaces where crew members can relax during their off-duty hours. Depending on onboard facilities and operational conditions, recreation can include television, internet communication, exercise, reading, and simply spending time away from the working areas of the ship. The engineering spaces are a completely different world from the crew accommodation. Deep below the upper deck, the engine room contains huge machinery surrounded by pipes, valves, cables, control panels, and monitoring equipment. The sound and vibration of the main engine create an unmistakably industrial environment. Engineers must carefully monitor the machinery because the propulsion system is the heart of the vessel. Without reliable propulsion and power generation, a ship this size cannot perform its role effectively. Another fascinating aspect of the OOCL Hong Kong is the way cargo operations are performed. When the ship reaches a major container terminal, enormous shore-based cranes begin unloading and loading containers. These cranes can reach far across the vessel and move containers individually between the ship and the terminal. Because thousands of containers may need to be handled, cargo operations have to be carefully planned. The containers are not placed randomly. Their positions are calculated according to factors such as destination, weight, stability, and loading sequence. Heavy containers may be positioned lower in the ship, while other containers are arranged according to the ports where they need to be unloaded. This careful planning helps maintain the vessel's stability and makes cargo operations more efficient. The OOCL Hong Kong was also significant because of its arrival at European ports. In June 2017, the ship made history by becoming the largest container ship at the time to serve the European market when it made its maiden call at the port of Felixstowe in the United Kingdom. This demonstrated how ports and shipping networks were adapting to accommodate a new generation of ultra-large container ships. The ship's construction itself represents an impressive achievement in marine engineering. Samsung Heavy Industries built the vessel at its Jeoye Island shipyard in South Korea. The OOCL Hong Kong was officially named at a christening ceremony there on May 12, 2017. It was the first of a series of 6 21,413 TEUG-class ships ordered by OOCL from the Korean shipyard. From an engineering perspective, the most impressive thing about the OOCL Hong Kong is not simply its length. It is the way thousands of separate systems have to operate together. The hull must withstand enormous forces from waves and cargo. The engine must deliver continuous power. The navigation systems must keep the vessel on course. The electrical systems must provide reliable energy. The cargo securing equipment must hold thousands of containers in place. The crew must monitor all of these systems while maintaining safety throughout the voyage. Safety is one of the most important parts of operating such a large ship. The vessel is equipped with systems and procedures designed to respond to emergencies at sea. Fire detection and firefighting equipment, emergency power, communication systems, life-saving equipment, and established emergency procedures are essential parts of modern container ship operations. The crew is trained to respond to different situations because the ship may be hundreds or thousands of kilometers from the nearest port. The OOCL Hong Kong also demonstrates how the shipping industry has changed over the decades. Older container ships were already considered enormous when they carried several thousand containers, but modern ultra-large container ships have pushed capacity far beyond those earlier limits. The OOCL Hong Kong's 21,413 TEU capacity represented a major step in this development. Its size allows a huge amount of cargo to be transported on a single voyage, which is one reason large container ships are so important to international trade. Imagine standing beside this vessel at a port. From ground level, the hull would rise far above you. Looking along the length of the ship, the bow would seem extremely distant, while thousands of containers would form a huge wall of cargo above the terminal. When the vessel leaves port and slowly moves into open water, its enormous scale becomes even more obvious. Once it reaches the open ocean, the surrounding water makes the ship appear almost like a moving island. And yet, despite its enormous dimensions, the OOCL Hong Kong is built around efficiency. Its purpose is simple but incredibly important: move as much cargo as possible safely, reliably, and efficiently between major ports around the world. Every voyage connects manufacturers, businesses, retailers, and consumers across continents. The vessel's name also reflects its connection with Hong Kong and OOCL's maritime heritage. The ship was originally part of the OOCL fleet, and today vessel operations exist within the broader shipping structure associated with COSCO after the acquisition of Orient Overseas International. Current maritime data identifies the vessel as operating under the Hong Kong flag and records its continued presence in international container shipping. When you look at the OOCL Hong Kong from a distance, it is easy to see only a massive ship covered in containers. But behind that image is a highly complex machine. It represents shipbuilding, marine engineering, logistics, navigation, port infrastructure, communications, and international trade all working together. The exterior gives it the appearance of a giant steel cargo platform. The enormous container capacity gives it the ability to transport thousands of units in a single voyage. The powerful main engine provides the energy needed to move the vessel across the ocean. The bridge and navigation systems allow a trained crew to guide the ship safely. The accommodation areas provide the crew with the essential facilities needed for life at sea. And the cargo handling systems connect the ship with some of the world's busiest ports. So, the final verdict on the OOCL Hong Kong is simple. This is not just a large container ship. It is a landmark in the evolution of modern maritime transportation. At nearly 400 meters long, almost 59 meters wide, and capable of carrying 21,413 TEU, the vessel represents an extraordinary combination of size, power, capacity, and engineering. When it entered service in 2017, it crossed a major milestone by becoming the first container ship to exceed 21,000 TEU, making it one of the defining ships of its generation. The OOCL Hong Kong shows us what happens when modern engineering is pushed to an enormous scale. Its journey across the ocean is more than a simple trip from one port to another. It is part of a global system that keeps products moving between continents. Every container on board represents something produced, purchased, transported, and delivered somewhere around the world. From its massive hull and towering container stacks to its powerful engine, advanced navigation systems, crew accommodation, and enormous cargo capacity, the OOCL Hong Kong remains a fascinating example of what modern container shipping can achieve. It is a true giant of the deep sea, built not for speed or luxury, but for strength, efficiency, reliability, and the movement of global commerce. And when this enormous vessel disappears over the horizon, carrying thousands of containers toward another continent, it leaves behind a powerful reminder of just how much of our modern world depends on the ships traveling across the world's oceans.